Hello everyone, once again welcome back to the channel. In today's video we are going to see how to set up the EKS cluster by using the Terraform, and this is a part second video of the continuation of the Jenkins Shared Library project. If you did not to watch the Jenkins Shared Library part 1, so I given the link uh, in the description box below. So if you find difficulty, means go to this project folder, and this is the website. Just go with this website, arishanshetty.github.io. In the left side you will see out the projects, and here filter it out as a DevSecOps. You will find out this video. Otherwise you can find out by the all. So this is the video, you can find it out this video. And basically this project is quite different, and it required some the advanced level of routing policies, and you should know about the route 53 and the grid manager, how we are redirecting our application from HTTP to HTTPS by the using of the SSL certification. So we are going to seeing up all those stuffs. Not only about this thing, earlier we are using up the ingress nginx controller, so is going to discontinuing from this next March 2026. So let me clarify. Yeah, you can see out in the console the community maintained in ingress nginx controller from the Kubernetes ingress nginx repo reached the official end of life in the March 2026. So for that case, I'm not using the ingress nginx. So I'm using the gateway API. So gateway API is quite different compared to the ingress. Ingress is not a simple setup, so it needs some knowledge and quite confusing on the first time. So when you are practicing up regularly, you will figure it out about the gateway API. So this is the gateway API. With the help of this gateway API, we can configure the different gateway classes like uh, Nginx proxy, Envoy proxy, and a lot more. We can do it. And HTTP route and TCP route to GRC route. We have multiple options by using the gateway API. And here, the main thing in this project is with single load balancer, we are accessing the multiple applications. You can see out in the left side, there is a single node balancer, right? So we are accessing the ArgoCD, Grafana, Prometheus, Kibana, and my application 3 tier. So we are going to seeing how to implement this all those HTTP routes in this project. We are going to seeing up, and one more is not the this one. We are also seeing up giving a network policies. So front end is don't have the permission to access this server. I mean MySQL pods. Only backend and the MySQL have the access. So we are going to seeing up this network policy as well, and the reference grant not only giving the permission to the all the namespaces, only giving the specific namespaces. We are seeing up the reference grant also in this video. And the one more is uh, we are seeing up the config map, how we are going to mapping up of our front end load balancer, no sorry, front end applications, how we are going to mapping up the nginx config files. And here HPA, we are going to seeing up how this is going to handle the pressure of the CPU utilizations and how they are spinning up to the HPA. We are going to seeing up in this project. And the MySQL pods, here you can see up, this is we are going to seeing up as a dynamic provisioning in this MySQL, and the MySQL 0 as working as a primary, and the two replicas which is working as a secondary MySQL pods. So stateful search we are going to seeing up, and pod disruption budget we are going to seeing up all those stuffs in this project. Not only this, installing the Elastic Stack, so getting the logs from the container and shipping that logs or nginx logs or application your logs, everything is going to shipping to the Elastic Kibana dashboard. This is a customized installation of Elastic Stack, and one more is observability in the Grafana and the Prometheus. We are going to seeing up this those stuffs, and one more is Kyverno. How we are going to registering our pods in the particular namespace or cluster wide. We are going to seeing up all those stuff in this project. This is not a quite easy to understand. So somehow if you learn this about this concept, if you will get a confident and easy to implement any other microservices projects. So let's begin the project. So if you did not watch about the previous part 1, if you are okay with the Jenkins Shared Library, or you can continue with this part 2 video. Let's begin the project. Yeah, here before going into the project, I will show you one thing. For the we have to create EKS cluster, right? So for the EKS cluster, this is not a demo purpose. You at least you have to spend the $2 you have to spend, because we are using the some 4 instance. This is not very nah, we are not using the on demand, we are using the spot instance for the demo purpose. So that's why is the amount is quite less. Let me switch it to the EKS Terraform. Let me do it in the terminal. Git branch. Yeah, we have all those branches. You should know about something branches commands also, and switch it to the EKS cluster. Git code EKS Terraform. Commit. Oh, I did something edited. Yeah. Edited. Yeah. Now git out EKS Terraform. Yeah. If you not get it, just refresh the page up here. It will come. Yeah. First, I will run the project. Later, I will going to explain it what I am doing up here in this project. A few things. I'm not going to on the longer video. Let me execute it in it. So here, what will happening? So Jenkins server I am executed earlier. So that's why it's saying up. We can't able to do it. Just reconfiguring it. Terraform init reconfigure. They're saying the command up here. Do this stuff. Terraform init reconfigure. Before doing this one, you have to replace in the backend your bucket name, right? And rest everything is fine. And make sure your bucket in the which region, right? These two things you have to replace up in this project. So if you are comfortable in the GUI, you can do it, but it's quite complicated. But because we installing the grid manager policies and the application load balancer policies, metro servers, add-ons, VPC CNI, we are installing a lot more. That's why I'm using the Terraform. So you should know about the Terraform little bit knowledge. That's why. So reconfiguring is going on. Yeah. Now Terraform validate. done, and format done. Now this is the file. In this file we are using the 1.35 cluster version, and let me execute first. Terraform apply var file hyphen dev dot tf and hyphen auto pro, right? Hit enter. Yeah, it will take approximately 50 to 20 minutes is going to take. So before applying, just take a plan. We'll get some idea. So I'm sorry to showing that one. And basically this project, I mean cluster will spin up in the episode 1, and the cluster name is my cluster, and this is the version of the 1.35, so latest version. This is the on demand, no worries, we are using this port instance. You can see up I listed over here. So this is just a name, don't worry about it. And the add-ons, the required add-ons, here we are not installing any Calico over here in this project. We are using the VPC CNI. Inside the VPC CNI pod only, I mean network CNI. So we are enabling the network policies. We are going to sync up all those stuffs, and core DNS, resolving the DNS namespace, and kube proxy communication between the prods, and the EBS CSI. This is required for the MySQL, because we are provisioning the dynamic storage, right? So that's why we are provisioning. And the version, you keep it in mind, this is the latest version. In the future, if you are facing any issue, means just replace this as shown in the web console, right? And the metric server will help out to scale up our pods like HPA by using the horizontal pod autoscaler. That's it, simple. And one more you have to check it out in this project is ALB policy. This policy I already did it because this policy will going to help uh, to the create of the network load balancer with the help of the application load balancer controller. So ALB controller I am using right now is 1.17 version. So you have to update it up in the future. If in case if not work this version, I will going to show you how to find out this ALB version. Give me a minute. Yeah, and here the service account going to creating up, the service account going to communication between the application load balancer, because we are um, hosting our applications, right? And accessing, you should require some role access. So with the help of the service account is going to communicating it with the help of the OICD, right? And that's it. Let me show you how to find out this version. Now there is a command I forgot on how to find out. Maybe helm repo search. Yeah, this is a command. Maybe this is not command. I will come back. Yeah, the command is quite different. So this is the command. Yeah, this command will showing up the list of the version. So always go with the back two versions of the AWS load balancer controller. So this is the version I am right now I am using up. Even I am not using the previous version or this version, the chart version, because it is in the beta stage, or it is in the testing stage. So that's why the chart version right now I'm using the 1.17.0. So like that you have to find and update it up. And one more, here we are generating the certificate. So for generating the certificate, here we have to create one of the policy uh, to communication between the grid manager and the hosted zone of the route 53, right? So this policy, what we'll do is going to check hey route 53, just give me the list of the hosted zone. It will give the uh, with the help of the service account, we have this type list of the hosted zone. So based on that, and the hosted zone by name is going to listing up, then it will issue the certificate. I need this type of a domain certification, just verifying it, this domain is qualified to give a TLSL certificate. So this grid manager will going to help, so with the help of the service account. This is the one thing you have to uh, check it out. So this one I can't do it in the normal way, so that's why I'm doing in the Terraform file. And one more is Jenkins file. I tried it, but somehow it's failing on the installing file application load balancer. Without when I remove the ALB TF file, then it will work. So you can try it out if you like to explore it. Means coding, right, recording. Yeah, let me finish this one. um yeah, let them finish. I will come back once you finish. Yeah, the cluster is created. Yeah, the application load balancer ARN and certificate ARN. This is related to the role, right? Role ARN keys. So we set up the ready. Let me check. Is anything updated? Yeah, I'm not updated anything. So if you've done any changes, just save it and check out it. Check out to the deployment. So here, uh, I did it in the order wise. So don't just confuse by doing the project. So I'm not saved this one. Let me save it. Out. Yes. Out. Comment. Yeah. Up here, the first thing, we have to generate this certificate. Before creating our application, we have to generate the certificate to access the via the HTTPS, right? So the namespace we have to create, one thing is gateway and the gateway class. Two things we have to create it up. Before going to here, just go with the readme file. So here I given the commands to execute the flow one by one. So just update it up, just explore it. It's or yeah, I don't have access because I'm not updated anything. Don't just copy paste the command, just type the commands, you will get memorized in the future. You see get notes. Yeah, we have the access of my cluster, right? So now we have to install the grid manager. So this is the helm. So grid manager we have to install. We have the policies already, we covered it in the Terraform, right? So this is the uh, command of the Helm to install the grid. I given the link also over here to get the chart version, and just let me wait. So in your machine you have to install the Helm also, and kubectl, ekctl, and the Terraform you have to install it in your machine. I forgotten to show up this all those stuffs. And you can search out the version, exact version which one you are using. And one more, the version right now we are using up 1.19.3, right? So you can see up here the version. So that's why I'm saying in the future also just update this version. When you are installing something by using the charts by the Helm, you have to find out the list of the chart version, then you have to update it up, right? So one more here, don't just blindly copy paste this command. There is a something you have to edit up here. So I given here you have to replace your account ID, AWS account ID, because you configure route 53 in your machine, right? So that's why to get the ID in the console, you have the command. This is the ID. Just copy and paste it over here. Don't just yeah, just replace from here to here. Yeah, it looks like this. And if you find difficulty to get the account name, I will show you one thing how to get this one. Go to the up here. I will find out in the top. You can see out this one, copy this one, the account ID, and paste it in the service account command line, right? 457. And once you update it, just copy and replace and execute the command. So this service going to work on the grid manager's namespace. So if you're facing any difficulty while doing up this setup, you can use the Helm uninstall grid, and again you can reinstall it. So I did not show you how to set up the route 53, right? If you are new means you have some confusion, right? Let me show you that one also. So this is my project. You have the right, you know about the website, and up here you will find out the two videos how to set up the route 53 in the AWS console, as well as how this one you have to purchase the domain in the GoDaddy. You will get around 250 rupees per year of the, for the demo purpose you can purchase it up file for exploring purpose. So how to set up in the namespace, this video is going to help to show up how to set up the namespace. If you already have the idea about it, no worries, you can go through with this video, right? So that's why I'm saying this is not for the who are thinking about the cost, uh, who are having adventurous mind. You can, this is the video for that persons, right? Is installed. Don't worry about this warning sign. Now the version is installed, and you can check it out. kubectl get or namespace of grid manager. Yeah, the all the pods is everything is work up and running, right? This is not a custom one. And the API gateway link, this link is right now is the version is 1.4.1, right? To get the latest one, I given the link above here. You can go with this link also. Otherwise, if you need the latest one, Gateway API Kubernetes install. So go with this version, this gateway API. Yo. CRD. Yeah, this is the link. Uh, go with this link. Introduction Kubernetes Gateway API. So up here we will find out the two types. One is standard channel. This is the stable one. So you can use up this version. Currently the version is 1.4.1, the same version it is in the GitHub repo. In the future, just replace it with this one. And this is the experimental. These have some more additional routing policies, so you can use it this experimental install if you like to explore on the more, right? So let's install this one, copy it. So it's installed all the related. We are focusing only HTTP route and the gateway class and the reference grant. So this all this TRDs is installed. So you can explore the grcp also. So if you install the experimental, you can do it the TCP routes and some more, and grcp routes. You have additional access over there, right? And kubectl get crd hyphen grip gateway. Yeah, by doing this command you can list it out. You can confirm it. The gateway API is installed, right? Yeah. Now next we have to install the Envoy Proxy. Envoy Proxy also is the one thing. The version is also defined over here. Let me show in the console. Let me access over there. Envoy Proxy all connect. Yeah, you can install by using the Elm also, or you can use it by the Kubernetes this version. So I'm using up this Elm chart. So by using the Elm chart, this is the command line. So in just copy and paste it. So the version they already specified it, and the namespace Envoy Gateway system is creating up, right? So that's why I'm saying again and again, just go with the latest version always. I know in the this will not work in the future. That's why you need patience also while doing this project. If you do it in the hurry, you can't figure it out anything easily. So instead, you can use the Nginx fabric also, uh, gateway fabric, Nginx gateway fabric instead of the Envoy proxy. If you have the idea about the Nginx fabric, so that's it. Rolling up. Yeah, let me see his board is working or what. Still completing the creation. Yeah, this one done. Yeah, is now ready. Now once it's ready, just let's move on to the installation part of the grid manager, everything. So up here, go one thing. Yeah, don't get confused while doing the project. Just go with the flow by flow, right? And here, before applying this one, you have to replace this your mail id, right? You have to replace it up. This one is not a temporary credential issuer. This is a production grade certificate issuer, TLS issuer. So your domain should be registered and it should be working. This is the name, arishetty.xyz. I will show it in the Route 53. Same name I configured in the Route 53, and the Route 53 is I created in the AP South 1 hosted zone ID. This one, how to get this hosted zone ID? You have to replace all those stuffs while creating the cluster issuer. Let me switch back to the console. Go to the Route 53. Yeah, here you will find out the OSS zone in the left side. Otherwise, yeah, click on here. I created the OSS zone already. You have to do the, I can't able to show it up here because it takes time consuming, that's why. And how to find out that one? Hosted zone ID. I taken previously. It forgotten to identify where it is. Ah, here maybe. Yeah, when you expand this one, you will get the hosted zone ID. Just copy this one and place it over there in the cluster issuer, and you can see out here when we are creating up, there is a one of the txt file we are going to creating up here, right? Copy that one and replace over here. This is most important, otherwise the certificate manager will not work. So that's why I'm saying this is not for the who are thinking about the cost. Right now on the cluster namespace, I'm not right. kubectl apply F. One, right? Now cluster is issued. Now go to the certificate. So in the certificate, you can see up here, the certificate will store it on the namespace of the gateway, right? And the secret name is arishetty.tls. Just replace this one also. And the cluster issuer reference is why? Because the kind version of the cluster grid manager is cluster issuer. That's why, right? And the DNS namespace, we are not taking the certificate with a single domain. With the help of giving the star subdomain also, we are getting the TLS certificate. So that's why you have to replace this also, these two things, everything, right? uh, don't just speedily do the project, just figure it out step by step and see what you are doing the project. kubectl apply road 2. Yeah, once you are gateway not found, your gateway is not created. is already done. Create. Okay, no issue. Let me create 0 1. Sorry. Yeah. Yeah, now is certificate is created. One thing you should know about here. Yeah, you can see up here in the terminal, it should come to the true. When it should come to the true, it tells your certificate is validated with the help of the Route 53. So let's switch back to the Route 53. So up here, one file is added up here in the record, right? So can you remember the service account and policy about the grid manager? So that's why we created the service account for the grid manager for this purpose only. So it's created up, it's validating, and once it validated, it issues the certificate, TLS certificate. Approximately it takes 3 minutes for the issuance. Right. Let me pause the recording. I will come back once it come to the true. Yeah, it's came to the true. Can see it up. So now certificate is issued. Now let's move on to the Envoy Proxy. So in the Envoy Proxy, you can see up here, the provider is Kubernetes, and here the service beta Kubernetes version is we are using the network load balancer. Target type is IP, and this is internet facing, not a internal load balancer. And the load balancer target attribute is preserve client IP enable true, right? So let me show up in the load balancer first thing. When we this is a just customizing our Envoy proxy, so use this network load balancer uh, to exposing our application, right? And let me apply kubectl apply is created. Switch back to the browser and let me refresh. Yeah, there is no load balancer presently is not created. And the gateway DNS. So this still it is not created the load balancer right now, and few things we have to replace up in this section. So this gateway DNS tells we are using the let's encrypt in the Route 53, which is issued, and the external gateway class name, and the listener is 80. So all the HTTP listeners will accept, but it reroutes to the HTTPS with this domain. What the subdomain will come, it reroutes it to the harishetty.xyz. Here also you have to update it up your domain name, and this is a subdomain. I'm just given the white card. I can't able to give if we have multiple 10 to 15 of its subdomains. So it is quite lengthy of the ML file. That's why I given the star. And this one, our certificate is stored on Harishetty TLS. If you change the name, you have to give it, and where your secret certificate is stored in the gateway. So certificate it is Harishetty TLS. This is the name, and it is stored on the gateway. So that is the point, right? So just update this one also. Let me apply. Yeah, is now created. Still the load balancer is not creating up. So once we apply the gateway class, this is the entry point. This is the entry point. This is saying use the Envoy proxy, what the customize was done. So with the help of the Envoy proxy, give me the a network load balancer. You can create number of load balancer by using the gateway class. You can use Nginx gateway fabric, some more another which one he has available. kubectl apply gateway class. Yeah, now gateway class created. Now we can see it out. One of the load balancer will create. You can see it is in the internet facing, not the internal. What we defined in Envoy proxy of the YAML. So same it will preserve here. Right, it will take the 2 to 3 minutes to active state. Let's move on to the next. So HTTP redirect. Yeah, here in the HTTP route, this is not exact of the application of rerouting your application. This is a policy related to rerouting to your application from HTTP to HTTPS. The name I given over here, it will place on the gateway namespace. So the parent reference is external gateway. This is the external gateway, right? So it will apply over there the HTTP. So if in case anyone is hitted to the HTTP ArgoCD dot your domain name, it redirects to the rule to the this. So if you have a multiple application, means you can give it up app dot dot xyz. So like this, you have to update it up your manifest file, right? So this is a simple one. Still your application is not ready. Let me apply this one right now. It will redirect. It will get easy when we are doing the project, right? Done. And the HTTP, this one is the like ingress, think like that. So with the help of the HTTP route, we are it is placed on the, you can see the backend reference is ArgoCD. It is using the port 80. The service name is the ArgoCD server. So give the it is give the name as a hosted the host name as a ArgoCD with your name. You have to replace all those this YAML file in this up here. The section name is HTTPS, right? It redirects to the HTTP and it moved to the HTTPS section. So this is related to HTTP, same as the Grafana. You can see up here the namespace it is placed on here in the Prometheus namespace. The service which is Grafana, using this table Grafana, you have to know better which service is exposing the application. And this is the Prometheus. This is the Prometheus service name. We are going to sync up all those stuffs in this project, and the Kibana for this is related for the ELK. This is the application 3-tier application. Up here we can use the weighted. So I tested this one. Maybe we have the problem in the application in the front end. The backend is actually quite working. So let me say it out this both way. Weighted the policy as well as the backend, exposing the backend with the same service name, I mean HTTP route. We're going to sync up all those stuffs in this project. And the grant, so in the grant you can see it up. So when you are using Envoy proxy or gateway class, so no other application is entering your gateway class. So when you grant the permission, only the particular namespace have the permission access to expose their application. So this one will going to seeing up the one by one step. For the understanding purpose, I'm going to show. So I'm granting the permission, right, to the ArgoCD, where This HTTP route, use it and give the permission, this ArgoCD namespace, they can access the application. So if you, in case if you created the dev namespace, so if you like to access that application, it will not access. So when you give the grant reference grant permission, then only it will get access, right? Let this one, we will do it after the creation is one by one. Let me show it afterwards. Yeah, this is completed. Now move on to the Grafana and the ArgoCD installation, Prometheus ArgoCD installation. Right. So everything I given here, the ArgoCD helm chart to get how to get, I have shown in the previous already. So let me install the step-by-step manner. Let me install the ArgoCD first. So this is the command going to help. Yeah, is updated, and you can find out the chart version. So right now I am not using any chart. Let me create first thing the namespace. And one thing you have to observe here, I'm giving a customized. Here I'm customizing the ArgoCD installation. You can see up here the cluster IP. So when you're doing the installation of the ArgoCD, you can find out like patching up the load balancer, right? Recording. Yeah, the recording. Yeah. Yeah, here what I'm going to, I'm not exposing this application. I mean, I am not creating any load balancer for a particular ArgoCD. So up here I am saying use the cluster IP and the insecure. This is a custom YAML. This is going to customizing it. So this is the customized YAML. If you like to do lot more, I mean customization like Prometheus values, this one I'll come up once this one was done. Customization, this is the customized Prometheus value. So like this, you have to store up in the file of the ArgoCD values. Then you have to specify the namespace as well as this file, right? So now ArgoCD install, this is the second way. And to get the password, just take the password. The password command also given here, don't worry. If in case this command will not work in the future, just copy this command. So this, let me take the password here and store it on the side in the notepad. ArgoCD. Yeah. Now we have to install the Prometheus. So before installing, let's update the chart, and you can search out the version. Yeah, you can search the version right here. What are the versions we have right now? So currently I am not specifying any version right now. I am going with the default version. So let's first create. So before doing this one, you have to, yeah, I'm specifying it, I forgotten to say. Yeah, this is the version 81.0.0, the version Prometheus and Grafana I am using up. Let me search over here. Yeah, there it is, 81.0.6. So yeah, this is the version exactly same. But the what will happening, I'm used this version in the earlier, it not quietly working properly. maybe this version or different version. I did not remember properly. So this version is working exact what I am expecting. So if in the future also just update the version. Otherwise, if you did not specify any version over here, it will apply it up over there. And yeah, and one more, in the Prometheus value, before applying up, you have to change something. So in the Grafana, you can use the load balancer, but it will create the uh, one more load balancer. And one more here, you have to specify your domain name, right? And this is limiting our resources. So this is a customized one, the what the Grafana will give, that is quite higher. So that's why I'm specifying up the limitations, and the Prometheus also. And one more you have to keep in mind, the storage volume climb is I am using the GP2, and this is quite maybe they are using the 10 GB actually, and I'm using the 2 GB of the elastic block storage. And the Prometheus, the static matrix I'm using up here, and the Prometheus node exporter I'm using. So in the future case, if it not working the version, just update the version, right? So let's copy it up here. The command is what you're executing. You have to know properly why this command is necessary. No such, oh sorry, I'm not in the particular perfect. Yeah, so here I'm saying install this stable Prometheus community cube Prometheus stack and the version 81.0 in the namespace. Take this value, customize value, and apply it when you're installing. So it's simple. So if you changes anything, just you can use the upgrade instead of the install. So you can use this version also. I am right now I'm not using the black box. So reference grant will see it out afterwards. This all those stuffs. Let them finish. Yeah. Now he is Prometheus and the Grafana both is installed. To get the password of the Grafana, Prometheus, this is the key for the generating password. And the password where I get this is the Grafana. Yeah, to get the password, get your Grafana admin password by running. Yeah, this is the command to get the password. Otherwise, if you're not getting the password, this is the command, simple short command. Yeah, this is the Grafana password, right? Yeah, we done two things. uh, we have to do it something. We have to access the ArgoCD, right? ArgoCD and the Grafana. Yeah, move back to the here and where we left HTTP. So in the HTTP, you just observe one thing. We have to access the ArgoCD, right? It is in the cluster IP, not in the load balancer. So I'm saying HTTP route, the name ArgoCD route, you place it in the default namespace and use as a external gateway as a HTTP section. Just reroute it, and the namespace, I mean in the hosted zone, I gave one as a ArgoCD arisheti.xyz. This thing you have to replace it up your domain. And the rule I am saying, the Argo server, this is the server, this is service which is working in the namespace of the ArgoCD. The application is hosted on the port 80. So I'm saying up to get the proper service name. I will show you one of the command kubectl get service, yeah, and the namespace in the ArgoCD. So you can see up here the ArgoCD server cluster IP. You can see up the type is cluster IP, and the port is exposed on the 80. This is the service name of ArgoCD. I am specifying over here in the backend rule, which is 80 port, access it, and the service name is ArgoCD server, right? So this is a simple one, and we are accessing the Grafana as same as it is ArgoCD. What do you understand? It is in the service name is stable Grafana. Let me find out that one is Prometheus stable Grafana. This is the service name of Grafana accessing up. This is the port, right? So, and the name, the domain name, and the Grafana, and the HTTP route. Again, I'm creating the Prometheus. This is the Prometheus accessing up stable cube, where it is that operator. Yeah, yeah, this one. You can see up the port 9090. I specified over here 9090, right? And the Kibana is still we not configured it. It will get an error message, and the 310. This is two things is pending. And here we can see out the weighted zone. This one I tested it, but the application is getting error on the front end, so I commented out. You can exploit this one also. I will show you the both way, and the match with the single 3-tier RGShetty.xyz with a single domain, URL. We can access front end and back end. So backend rule also returned out here. This one will going to sing out in this video also. So the reference grant is nothing but granting the permission. Let me see out here in the ArgoCD. Yeah, I'm granting the permission in namespace. What are the services you are exposing via the HTTP route? So I'm giving the permission access that service. So same as it is, I'm giving the granting the permission on each namespaces. If you are creating any dev namespaces, so if you're not giving any grant permission, accessing that application services, so that application will not going to accessing up. So right, let me apply, move back to the console. So these two things we have to apply it, right? Just apply the HTTP. Let me apply this grant afterwards. kubectl apply, and then 7. Yeah. You can see out there is no pod prob is created, right? Now, yeah, move back to the browser where it left. Yeah, in the route 53. So let me create the ArgoCD, give the proper which one you created, and the route table is select the network load balancer. Don't select the application classic load balancer, select the network load balancer, and here you have to select the Mumbai and the classic network load balancer. Select this one will going to appear if you done properly, means it will appear, and create the record. So click on the view status. It should come to the in sync over here, not the pending. Let's wait. It takes a few seconds. That's it. Yeah, now is record is added. So let me access it. Yeah, you can see up here we can't able to accessing up, right? So we did not given any permission of granting. So for that case, uh, I'm not applied earlier. Now I am granting. Yeah, now everything I granted this ArgoCD Prometheus and the default in any application is uh, ec- uh, created in the default namespace, so they can also accessing it, but you can remove it afterwards, right? Now let's access it. Now you can see up here we can able to accessing up, right? So with a single load balancer, let me show you the load balancer. Is anything is created on more? No, there is only one load balancer up here. We have the multiple application, so one application right now is accessing up, right? uh, Let me set up the Argo CD first thing, admin, and what the password we already copied over here. Copy it and paste it over here. So we can't able to memorize this password, right? User info. Click on the update password, current password, and this one I'm going to give admin 123. Update up here. Admin 123. Right. Yeah, we configured it. Let me apply. Admin 123. So don't create anything right now. We have to do some more lot of stuffs, right? So create the Prometheus. Maybe I tried this one. This one is not accessing on this sometime. Okay, Grafana, we have to set up it, right? Now click on the create record, and now we are going to adding the Grafana, right? Traffic route is network load balancer, and the region it is in Mumbai. Yeah, create record. So we created the 3 records and we have the access with a single node network load balancer. Let me access the Grafana. Just copy this one and pasted over here. So we can able to access it up. Click on the advanced, click on the proceed. So it's getting some issue. So earlier also I tried it, but it's not getting properly. Yeah, now Grafana is quite working. This one, something I did wrong. Why is getting error? Right. So let me check after this one, Prometheus. And the Grafana password, this is the password. And the email is the admin. The password, just paste it, login. Let me update the password first thing in the administrator, maybe user access, users. edit user. Yeah, correct. The password is up here, and admin 123. Correct. Yeah, I created this one also. Three. Right now we have to import the dashboards. Right. So for the dashboard, Grafana overview, something is showing up. Kiblet. Yeah, node exporter. You can see up the all those details about the node exporters. Now we have the customized port, IDs. Click on the new on the top in the dashboard. Click on the import. So ID I mentioned 15661. Case dashboard, and the data source is Prometheus. Click on the import. Yeah, you can see out the wonderful insight about your uh, cluster details. So you can see out the we have the 4 nodes right now, and pod limit is 17, and memory usage is already consuming 109 and the one of the node. You can see it up totally we have the 40 right now. Yeah, right. Yeah, one more dashboard is called the import 17375. Yeah, this is related to the pods. You can see out all the pods will showing up here. One more ID is there. I don't know it will come or what. 21410. It is overview import. Yeah, something you will get out related to the cluster. This is related to the cluster. This ID, right? 21410. Yeah, we covered. Let me access this one more time. Not found. I will check it out. But scrapping was working fine. Right, let's move on to the next. What the next? We covered ELK. We have to set up, right? So ELK is one of the pending, and the Kyverno. So before, let me install the ELK first. We are moving back to the Kyverno afterwards. Yeah, move to the ELK. So in the ELK, this is everything is customized. Each installation. So let me yeah, same thing in the HAML. Copy. And here the one thing we have to check the version currently which version is chart is have in the latest. Currently we have the version 8.5.1. The same version it is specified over here. This is the elastic search value, the version, and the replica. This is what will happen. This is going to create the uh, dynamic PVC. That's why I'm specified to the one. Otherwise, if you not specified, is going to create three pods, stateful set pods. That's why I'm specifying to the one. You can specify as well as okay. And request resource limitations I'm given because it quite consuming the 2 GB of memory. So that's why I'm given its specific limitations. And GP2 I'm using up 2 GB, otherwise it is going to take a 10 GB of persistent volume. So I'm specified over here. And if you like to show up this something, how this I'm editing up these values means. So let me create first thing, this one, namespace. See, right now there is no value, think it like that. Just copy this one. This command will going to export what they are implementing. Here you can see they're saying I'm replications maintaining 3, minimum master node is 2. So same as it is, that's why I'm specified over here, just rewriting with the customized YAML file. And the version is image tag, which is, if you not specified, is going to take up this version by taking from the Docker hub. Right, resource limitation you can see up here, 2 GB RAM and 1 CPU core will going to consume. So that's why I'm sticking on to the 1 GB RAM and 1 CPU. So, and the one more thing I have to show you up here, you can see the 30 GB is going to climbing up. That's why I'm specified is 2 GB. So for the demo purpose is enough. So that's why I'm using the customized one. So you get a better idea. Just delete this one. Yeah. And once you edited everything, just copy it from here until here is okay. Yeah, you don't require to execute this one because we already specified in the customized YAML file, right? So it will take some time to come out. Let them finish. And Kibana also we have to search it up by using this one, the version, current version. Yeah, the same version. And the value same as it is was shown, the command in the Elasticsearch same as it is. Yeah, now installing the Kibana. For the Kibana, I'm not going to modifying anything, just I'm going to give the version of the image. That's it, simple. Just take up from here. I know it's quite confusing while doing this project. Same thing as here logstash and the file bit. Yeah, now Kibana and the Elasticsearch is installed. Now what we have to check it up, kubectl get ports in the namespace of elk. Yeah, Kibana, yeah, Elasticsearch is up and running, and Kibana is still is showing the one. It should come to the ready state. Let me install this logstash as well as the file bit. we have to take the password for the Elasticsearch, right? So let me take afterwards by setting up this one. So before applying this, yeah, let me apply this one. So this one also maintaining the one log stash. For the high availability you have to maintain 2 or 3, and this also giving to the 1 GB. Environment, I'm saying that use the password as a Elasticsearch. What you secret is stored up here. On the logstash pipeline, I'm just modified it. Go to and store it on the Elasticsearch master. It is for have the 9 2000, and use the password as which is stored in the secrets, right? And the mounts, this is related for the certificates, and the cluster IP we are using up. This bits is going to catching up, right now. Right now, apply the log stash. Don't do anything, just apply it. Let me access the Kyverno once. Where? Oh, sorry. 0 3. Yeah, now is applied log stash. File bit I am not installed right now, right? So what I'm going to do now, let me check this HTTP. So I am exposing this one. This thing is already available in hub here, don't worry, but for the use case, for easy understanding purpose, I am using that one. Let's take this IP, particularly this one. How to find out? Can you remember the command? kubectl get service, and the namespace is elk, and you can see the service Kibana, and the port is 5601, right? And this is name. Let's apply it, kubectl apply, and yeah, we applied it, configured, and the grant, I'm giving the grant. Let me give the grant. Grant was successfully done, and now we have to take the password, right? Where I left the password. Yeah, this is the command to get the password. Let's first access it up in the console. Create record elk. Oh, sorry, not Kibana. We have to give Kibana and Mumbai. So we have the access. So it's asking the username and password, right? So the username is Elastic. The password, which is there. Get the password. Yeah, retrieve the elk user password. This is the password. Oh, sorry, I did not switch it. Yeah, this is the password. It over here. Yeah, copy the password and don't change the password. Login. Yeah, we successfully logged in. So save it. Don't change the password this one, otherwise we have to replace all everything in the up there. So here there is no logs is presently shipping to this ELK stack. So in the left side you can see it in the logs. Currently there is no logs because we did not configure the file bit values. So let me do it that one. That's why you have to understand what is will going on when you're doing the project. File bit is done. Now what you will do, kubectl get pods and hyphen elk. So you can see it up, the file bit will place on the each node. So we have the 4 nodes, right? So let me do it in the wide. Yeah, you can see it out. We have the 4 uh, nodes, right? We have the 4 nodes. In each node the file bit will place on. This is like a work as a daemon set. So each node have their own daemon set. This file bit ship the log to the log stash. Log stash filter it out and ship this logs to the Elasticsearch. Elasticsearch will go into storing the values, right? So Kibana, what will do, this is a dashboard, graphical dashboard. We can't able to read out all the logs every time, right? So Kibana will visualizely we can give, it will give. So it's up and running file bit in each node. Me where it is, yeah, let me switch. Refresh. Yeah, you can see out here the logs is now we are getting. So this is related to the uh, container logs and something recovery, not dashboard. I will show you somewhere. It is there, I forgotten. I will show you. Now let's move back to the up here. So now Kyverno we have to set up, right? This is done. Kibana and ArgoCD, Prometheus, everything was done. So get back. Now go to the Kyverno, right? Go to the Kyverno. Up here, so Kyverno, we are restricting the deployment in the namespace. So before doing that, I will go to show the how the Kyverno official documentation look like. So this is the official documentation. So here we will get out the installation steps, setup, installation. So here, two things we have to keep in mind. So one thing is non-production installation. This is uh, going to maintain single pods. So there is no guarantee about the permission policies by doing this one. So the admission controller will work as restricting the if any unauthorized or different deployment of pod is placing into your namespace or unsigned images is placing up is going to validating by using the admission controller. So for the high availability, you can use this Helm script. So it's going to maintain the pods in the high availability in different nodes. You can see up to 3, but it takes consumes some lot more resources. That is quite challenging. For the demo purpose, I am using up Kyverno, this one non-production installation. Just copy that one. The command I have already given here and install it. So cosine we already seen about the previous version um, part 1 video, right? Still going on. Installation was done. So it's saying don't worry about the warning because it is a non-production Kyverno setup, right? And kubectl get pods in the namespace of Kyverno. So you should come to the ready state everything. Otherwise, this policy will not going to affect your policy creations, right? So I have here the 2 files. This is the test policy. This is I am not using the cluster wide, right? So I am using as a I'm restricting the dev, only dev. So I'm restricting the image. Only this related image is have permission to place up in the dev namespace. So I listed out here. It is come from the username, and you can test out by using your Docker profile ID. So right, and if it also came from the Docker ID, so I'm not giving the permission to the laptop latest. This one I'm not going to giving the permission, but you can also deploy by using any of the tag of the front end side or back end side and MySQL, right? So let me apply this one policy. First create the kubectl create namespace dev. Yeah, now this one is not a cluster wide implementation. This is a namespace of isolation. Kubectl apply and the iPhone 01. Yeah, now policy is added, is going to restricting up. Let me apply the just here I just comment it out. What will happening here? This is okay, fine. And the laptop replica is okay, no issue. And here I signed up. I mean, I'm saying if in this laptop I like to use this pod. I mean this image, Docker image, this one, right? This is okay, no issue. Now let me apply this one. Let me see what will I'm going to show. So you can see up here there is a violation. It is blocked, was blocked due to the following policies. So you can't able to placing up this laptop, but this it is not mentioned. So what I'm going to do now, I'm going to show up here front end signed. Let me apply. See, now it is applied because we gave one the front end signed. Any of it will place up here. The policy is not allowing, the policy is not restricting any tag over here, only restricting this one. Let me check. First thing, kubectl get pods and the namespace of dev. Yeah, you can see up the name is okay, but the image quite is different. Now what will happen going to do, I'm going to giving as a same as a laptop in the earlier page. Let's apply this one, kubectl apply to. See, now is going to throwing error. So what will happening now? Now I'm just uncommenting out this one. Just apply the policy. Policy is configured right now. Just make sure you given the laptop and apply it now. Now you can see it is configured. So it is allowed. Now kubectl get. See, now this one is removing the previous one which one is there, and new container is now live. So that is the use case of the Kyverno. And one more use case is there, but we are not using the hub here. That is enforcement of signing up the cosine. That is I'm facing an issue because of rate limit of the cosine and the this Docker. So we have to pay for that. For the demo purpose, you can understand how we can achieve this Kyverno and the cosine and this isolation of the namespace, right? Let me delete this demo. Now you get some idea. Yeah, now is deleted. Now Kyverno is setup was done. Now we have to set up this application, right? So don't require to set up this all those stuffs in the what normally what we are doing here right now. So let me set up it is uh, in the ArgoCD. Let's access the website ArgoCD, create a application and type the 3-tier app, and the project name is default, the sync is automatic, and the repository is, this is the repository, right? In your case, take your repository, and the revision is nothing but deployment, and the path, what the path, it is in the deployment where it is, this is the path. Cluster IP namespace, what I given the namespace I given to the prod, right? Before doing that, let me add up the Kyverno security. Where I left 6 and check it out. The in the namespace same as it is what we've seen in the demo, same, right? So I'm just allowing my particular uh, images, not the another one. Let me apply kubectl apply and the 12. So namespace is not here. Here create namespace prod, right? Apply is created. Now move back to the up here. Watch kubectl what get pods and the namespace of prod. Let me watch what will happen. Now click on the create. Yeah, it's placing up. Yeah, so it's not restricting up right now. So I have to show you something in it, right? Yeah. So backend is still not working. You have to understand the liveness pod and the readiness pod in this project. So here, when it comes to the live, this pod, you can see up the backend pod will come to the live. So what will happening? It's keep on restarting until the database is live. Yeah, now you can see up the MySQL is running and the backend pod will come to the live within a second on the next restart of the container. So you can see up here. It should come to the next restart, not should restart it now. Yeah, you can see up here the restart was happened is now running, the backend is running. Let me access this one, right? To accessing this one, you have to go to from the Kyverno here, cd right and cd and http and apply kubectl, apply and what 7. Yeah, his 3 tier is applied and the grant also we have to give. Yeah, now everything was created. Now let's move back to the console, create a record 3 tier and network load balancer Mumbai. Yeah, now let's access it up. Yeah, we have the access, you can see it up and db. Yeah, we have, let me add up these some values. Let me have open. So now data is adding up, so let me add it via the mobile. So you can also access it via the mobile, you can see up in the screen, right? I'm going to adding up the data. Yeah, let's refresh the page. Here is added from the mobile, right? So we seen about the Kyverno and the reference grant, HTTP, everything. So here the one more thing I have to show up something in the HTTP route, right? The backend we have to access it up. Let me show up here the type the health. So there is no accessing, but we have to give the roles in the HTTP. Where it is, yeah, the HTTP. So right. So let me apply this match and comment it out. That this is the backend SVC. We have the transaction as well as the health. and this is the port with the backend services which is placed up here, the name. Let me kubectl apply 7. Yeah, now move back to the browser, refresh. Yeah, you can see out this the health check, we can access it. Let me access the transaction. See, we can access the transaction data. So with a single HTTP route, we can access the front end and the back end. So we can also access the multiple applications with a single load balancer by using the Kyverno proxy. So you learn a lot more stuff. And one more weighted zone, you have to check it up, right? I have to check that one also. Let me switch. It will not working. I tried it. Let me show that one also. Yes. Maybe the cache problem is there. So the weighted is a front end I given as a 50, and the back end also I given a 50. So it will share the both resources. Let me add. Yeah. Uh, refresh. Yeah. Now it's now not getting, but it's switching up. You can see up here. Actually, yeah, it's switching. Actually, there is a issue in the this application, but it will work. Let me uncomment out. Yeah, done. Now you have to understand this first thing in the iterator application. Now easily we did it right. So a few things we have to keep in mind, and what the YAML file we return, you have to know. It is this one, right? Yeah, we covered everything right until here. We almost covered everything. Yeah, the namespace, creating the prod, uh, and the secrets. In the secrets, this is related to the MySQL secrets. I am storing up this user name as a root. So there's a command to encode. I mean decode. Yeah, encode for this. How I encode it, I will show you. Echo root is before. Yeah, you can see up by using this command, it will encode it the same password which is I stored up here. You can also decode it. That is a different command. Yeah, this is the password for the root and the MySQL root password. MySQL replica should work. It should maintain the primary and secondary. For the password, I am given the same as a root password, and the config map for the config map for the MySQL. So there is a one more way to do this. This is some oldest fashion and complicated way. Not a complicated that much of way, but is quite different compared to the another YAML file we have to install it. I mean service we have to install up. Raco something is there, and this is the MySQL config file. The primary config file is going to maintain the one MySQL. Let me kubectl get stateful set in the namespace of prod. Yeah, to prod MySQL. Yeah, this is working as a primary. You can see up here, and this is exact secondary storage. So this is only for the read axis, I mean storing up. This is for the write axis. It will work. So this command primary configuration will place up on this pod, and replica this will going to placing up on the this pod. So it's going to maintain, and the initial SQL I am placing up the database. Here you can see up the database I am doing up in the initial SQL. So once the MySQL was creating up, it going to take the init container. You can see the 2 by 2, the init container and the MySQL container will work, and sidecar container will work. But sidecar container going to maintain the primary, secondary of the stateful cell applications. So let's move on to the head service. So here you can see up here the service I am using up for the MySQL. This pods as a headless. In the cluster IP, I'm given as a headless. If you given as a cluster IP, so it's going to create one of the IP, right? So if you given the cluster IP of none, is going to maintain as a MySQL 01 as a namespace, domain namespace, as a selector as a MySQL, and the port which is exposed on the 3306. And the stateful set here, this is the most important one. The stateful set is going to not creating the random stuff what you are seeing in the front end. This is a random stuff. Even if you updated any new applications or pushed into the GitHub repo, so it's going to create new or unique IDs, right? So stateful set is going to maintain this. If you delete the MySQL one, so let me delete this one, kubectl delete pod, and the namespace is MySQL 1. So I'm going to deleting up this one, MySQL pod, and after the pod is deleted, so you should come to the same name state, right? Yeah, it's going to terminating up. Get pod. Yeah, you can see up here is terminating. It come back to the MySQL 1 on the same state. Yeah, new container is now creating up with the same name. You can see earlier it was, you can see up earlier it was the 9 minutes, and now the new container it is on the 27 second. But see, the name is stated as a stick is going to sticking up your name by using the stateful set. So like that, we are using the stateful set as for the database, so we not randomly creating anything. And here replica I'm using up to, you can spinning up to the 3 also, it's going to spinning up is enough for the spinning. And the order ready is going to creating the order wise, not creating the all the stuff in the uh, at a time. So rolling update only one pod when you are deploying the new pod, I mean image, is going to deleting the uh, one by one pod is going to updating up. So yeah, template is okay, termination ingress, and the security context, this is the most important. We are not exposing this container as a root access, so we are using this one as a MySQL username. So this is the use case of the security context. And the pod affinity, this one is going to maintain, let me show up, 0 wide. can you see you something? Uh, MySQL 0 is placed on the 90, and the one more pod MySQL 1 is placed on the 109. So pod affinity is going to distribute the high availability. So if in case something happened on the node, uh, you can you can be able to access the data without worrying, because the another node is up and live running. So init container, you can see up here 2 by 2 layer, you can see the something initialized, the indication was showing up. So this is the initialize command, the command which will work. So init container left. So this is the exact image what I previously built in the Jenkins Shared Library, and this init command going to check the primary config and the replica config what we configured in the configuration file up here. This one, right, is going to check these two files. After that, it's going to check Unix server ID and the pod. Everything is going to configuring it, and the container, which is the main container, this one we are using up as a 3306. The port we are exposing up the same IP, same image name, and if you are using the different, we done the Kyverno policy, right? So it will not work. When you delete that one, it will work. So secret, and we configured in the secrets, and the volume mount. Okay, and the resource until limitation 1 GB memory we given, and the readiness probe. If in case it is not ready, it's going to restarting up frequently. Readiness. Initial delay is 50 seconds are given. Don't give the nearby 5 or 10 seconds. Give to the 15 to 20 seconds. The liveness pod. Uh, the liveness pod going to check, probe going to check whether the container is working or not. Can you remember the backend is keep on restarting it because the database is still not up. So once the database is going to check a pod just restart it. Now check the whether your required information is present or what. So it's going to check if the information present in the MySQL, then it's going to live running. Otherwise is keep on restarting every time. So replication sidecar is going to check regularly, is maintaining proper one as a primary replica in the MySQL 0. So sidecar will do that job. And the config map, in the config map, we are taking this config map, this one initial config. This data will be storing up on the empty directory. Empty directory nothing but is storing the temporarily. So once job is done, or once the data is inserted, is going to not storing up your data. It's just a one time case. That's why the empty directory will be use case. And the volume client I am using as a 1 GB GP2. So that's it, simple. And the service write, this is for the primary, for the write primary MySQL, which is this one. And the secondary read service I am creating for the MySQL 1 and MySQL 2, like that, for the read and write. And the probe, this is the most important one. The probe, what I'm just going to saying up here, PDB, for disruption budget, this is nothing but is going to maintain if you are doing the cluster upgradation, like draining up the one of the node. You have the 3 nodes and maintaining the upgradation of the 2 nodes. So this will maintain the minimum 2 MySQL pods, right? You should maintain, because we can't able to lose the customer, right? So it's going to maintain the 2 pods up here on the back end. This is the backend rolling update one by one. If the new image will come, rolling back update one by one. So replica is 2, and this is done, and the security context is 101. We using the app user. This is the app user. We're going to sync up that one also. This is the one of the trickiest. Somebody can't understand this one. Image pull policy is nothing, is if not present, is going to check in the local node if the image is present in the local with the name, this name. If it's not going to pulling up the new image, so is use the same image. Otherwise there is a one more, is the always. So what will happen, even if the image is done, even if you applied again, this one is going to pulling up the image from the Docker Hub or somewhere easier. So and one more is there, that is the never. So this what will do, this will not going to fetch any or pull any images from the Docker Hub or anywhere. So use the local one, it will use the local one. So you have better to understand that one. This is the security concept related to the uh, your what I can say, your upgradation of the pods. So there is not allowed, you can't able to install any applications given the capabilities of all. So your resource on limits and environmental host, right, the username which is stored on up here, MySQL secret, right, username, and pdb we same as it is, and the db password I'm not given over there in the secrets, I'm just specifying this one, web app db. So this one is specified in the backend database, and the pod container port is working on and the 4000 port, right, and the health check you can see up here, we can able to accessing up in the in the website, right. So liveness pod is going to check if health is okay, then is not going to restarting up. If the readiness pod, readiness pod, yeah, and service, this is right, simple. And the config map, this is the most important one. And the config map, I am not using the nginx config file which is given from, I am not hard coded this nginx file in the yeah, I will show you something. Go there where I did it. Yeah, go to the file up here, go to the front end. The front end, here there is a nginx config file. So in the docker file, just observe in the docker file, can you see anywhere in the nginx file I am just copying from hard coded here? No, I'm not hard coded anything over here. What I am saying here, I am giving the ownership as a nginx up here to the config.d. So what I'm saying, this default.config have the nginx file which is have some customized nginx configuration. This is the backend svc which is serving the data, I mean accessing the backend application business logic. So this is the custom one, and this is the log format. We can able to edit it up anything if like to update in here. If you hard coded means you can't able to edit anything stuff. So that's why the config map will work. And the front end is blue, and this is quite as similar as the back end, but few things is the name is changed with 101. This is to the nginx one, and the name same as it is, everything is same. Liveness pod, and one more thing, you can see volume mode as a config, and yeah, it will take it up from the config map. nginx config. Yeah, you can see up the volume mount as a front end config map. right? Config map which is present, right? So this is done. This is the green one. This is not working. You can explore it up, but everything was we covered it. But one thing, the network policy we did not cover it right now. So for the network policy, uh, I have to update it up something where I left. No, network policy. There's a quite a simple command over there. I've forgotten. So I got the command. So, when you implement this network policy, it will not work. So for that case, you have to edit up something in the network policy. You can use the Calico. Before doing that, let me showing up the something in the console. Go to the cluster where it is. Goodness gracious. Yes. In the AKS, networking here. Access add-ons. Click on the Amazon VPC CNI. Now, in the additional information, it will going to change up here. So, before applying this one, we have to check it up. Code. This is the command we are going to editing up. So you can use the Calico, but you should disable the VPC CNI. You need some info, little bit knowledge about this uh, related to the container networks. Right. So let me kubectl get pods and the namespace of the kube system. So what we are going to doing up. So this thing we are going to editing up. This config map we are going to editing up, right? This is a CNI. Paste the command, just paste the command, and not found. Okay, now take up this one and paste it over here. Yeah, it's pasted to the false to the true, and move back to the browser. Just to refresh this one. You can see up here, enable network policy is true. So now we can perform the network load balancer. I mean, sorry, network policies. So one more, if you're not installed, Calico is so by using this one, you can install this Calico. You can implement the network policy, but we have the default one. So by using the command patching up this one, we are using up, right? So let me access before, yeah, kubectl exe and the it code front end. One blue, access anyone, and I j and iPhone s. So I am in the front end. Now let me check whether I can access the MySQL. It is opened. See, it is opened. Let me access the same. Same in kubectl exe and so let me check. Oh, it's not working the command. So it's not there. No issue. So the front end have the access of a MySQL, right? And the backend, let me check the backend also. Yeah, backend is also opened and the MySQL is also opened, right? So now we should only access the uh, backend of the front end parts. So what will go to the network policies over here. In the network policies, we saying about this is network policy. I'm saying this is a match one which is matched and enable the ingress incoming and egress is outgoing accessing from the backend, not from the front end. So they can access the 3306. Let me apply this one kubectl apply and 13. Now I applied it. So let me check whether I am able to access the MySQL. See, now I am not getting any response immediately. You can see up in the earlier I am getting the response. So now I am not getting the response. So now let's access up yeah, backend. We can able to ping out the backend, right? Let me check whether our application is working or what in the browser. Where's the application? Yeah, this is the application, right? So our application is working without any issue and able to access the data and yeah, we can able to access the data on refresh up. We can able to do it, right? Uh, by we can implement by we implemented network policy with default patching up of the network VPC, right? And ELK stack we did not cover, right? About the Nginx, right? Yeah, now is front end cover. We create is anything is coming. It yeah, you can see up here the logs. You can see visualize it and the agents ID all four is working and Kubernetes everything we getting up. Yeah, pod names everything we are fetching the logs, replica sets, namespace. Yeah, getting and the logs also getting everything. Visualize, yeah, this one. Click on the visualize. Yeah, you can visualize by this one, right? So you've seen about all our stuff. Now the project is done, end to end of Jenkins Shared Library till to the EKS cluster creations, deployment EKS. I mean, shipping the logs, observability, certifications, network policies, single load balancer, Kyverno. A lot more stuff we learned about from this project. I know it's quite difficult to do this project, right? And anything I left it. Yes, we've done everything. So before closing up this one, we have to delete the resources. Otherwise, it consumes the uh, your amount. I mean, it will charge. So that's the to delete this one. Go to the this folder. Yeah, you should be in this folder. What you will do? Just go with the kubectl, delete, and the iPhone. So it's going to delete all the net, this one as especially in the gateway classes before you destroying up, right? So once you're done, um, yeah, by doing this one, I'm not going to do this one because I have to do some more things in this project. So execute this command, and one more now show you push and git checkout Terraform, sorry, EKS Terraform. Okay, still have the done. Right. Out. Yeah. Now here what you have to do, you have to execute the command terraform destroy hyphen var. Once you deleted that one, you have to perform this action. Var file hyphen the dot tf and the auto approve. I'm not doing right now. Just this command is enough to go. Is going to destroying your infra. After this destroying it, and one more step you have to do, that is you have to delete the uh, this volumes, right? Go to the EC2 up here, volumes, in the volume sections. So some volumes will be present up here because the dynamic provisioning will up here. Dynamic, this one will not going to removing automatically, so you have to remove in the manual way. So once you deleted destroyed everything, come here and click on everything and click on the delete volume. It will come. You do this action, right? We covered everything. I hope you enjoyed this video. So this video is going to help to understand about the architecture of this project. If you like this project, like and share uh, the video, and subscribe the channel. Once again, thanks for watching the video.